In this video, we're going to look at how to use the calculator to try and help me figure out when does a function have one or more imaginary zeros. And as always with mine, I'm using a TI-84 plus CE, but a lot of what I say will apply for pretty much any graphing calculator. Alright, so I've got one to get started with, and as you might remember, this is kind of our classic example of having an imaginary zero, since if I take that, set it equal to 0, and solve, here I'd take the square root, and that is basically our definition of I, is the square root of -1. So let's go ahead and graph that. I'm already in y equals, so let's hit x squared, subtract 1. Again, it's subtract 1, plus 1. Helps if I hit the right thing. Let's hit graph. So, the zeros is where it crosses the x-axis. So that means if I have a graph that doesn't cross the x-axis, does that mean it doesn't have a zero? That means it doesn't have a real zero. So if it doesn't cross the x-axis, that means no real zero. Now most of our functions are going to have a zero, at least in this level of class I'm making this video for, so I am going to interpret that to mean that this has imaginary zeros instead. Now unfortunately, the calculator really does not give me any hint about where that imaginary zero is. Is it a comparatively easy imaginary zero like this one, or is it going to be something a lot more complicated? Because our calculator is only graphing in the real numbers, I really can't tell by looking at this. Let's try a more complicated function. Now, we've got various theorems that tell us how many zeros to get. I'm not going to go into them in too much detail in this calculator, or in this video, because I want to focus more on the calculator. But we do have a theorem that tells us this has, at most, 3 zeros. And again, in the level of class that I'm making this video for, I'm generally going to expect that it will have 3 zeros. They may not all be different, but I'm still expecting it to have 3 zeros. So let's go ahead and graph that function. So I've got x to the third plus x squared plus 5x plus 5. And let's hit graph. Now, I am definitely crossing the x-axis, so I definitely do have a 0, and that 0 does look like it's at -1. Let's use my table to check. So let's hit second table. And again, a 0 is where the y value is 0. So yes, at 0, I'm at x is -1. So yes, I do have a 0 at -1. So I've got one of them, but I'm expecting to have 3. So I'm going to then use this graph and say, because I expect to see 3 zeros, and I'm only actually seeing 1, that means I'm going to interpret this to mean I have 2 imaginary zeros. Now again, unfortunately, the calculator doesn't really give me a way to find those. This is where I'm actually going to need algebra to find those remaining zeros. My calculator is just giving me a way to indicate that I do probably have them, but because I can't see them, they're imaginary.